Hello and welcome back to another video, and I have been meaning to experiment with this particular setup for a while. The tech thermoelectric thingy. So the concept here is it can cool very to like sub freezing temps and heat up to quite high temps. And it's basically just powered by electricity. There's no like in an AC, like a compressor required. There's nothing that says just all silicon based, all electric. I'm not going to go into very much detail about what this actually is made of, but it's multiple arrays of NPN and PNP transistors alternately, and what it allows it to do is to um, transfer heat from this side to the other side. So the other side gets hot while the um, what I'll say is cold side, from where the heat is being taken away, um, gets colder and colder. So as much heat you can pull off from this side, the colder it can get. So it can actually reach freezing temps, provided you have a good cooler at the back. So we'll try to do that. And this is, I think, I'm not sure, like a 6 or 7 amp unit. I'm not exactly sure. So I have my DC power supply here, and I'll be pushing it to the limits and see how everything goes. And how much current it's drawing, because that's going to be interesting as well to see. But yeah, let's get started. So the base of it is just ceramic plates on the top, and then some silicon glue just sealing it all around. Apart from that, that's about it. I have a old PC cooler that I'll attach it to it, but first we'll try it out at lower voltages to see somewhere like 1 to 5 volts, what sort of changes we can see and how much current it draws at that point. I have my DC current meter right here with me, so we will set that up as well. So I have that clamped, and let's zero it out and let's power this up and see how it reacts to it. So I think just from the get-go it will be off, so it's not pushing any current. And then I can go and set the voltage. I think it's set to 3. Let's set it to a bit less. um let's start with 1. So at 1 volts it's drawing around 0.2 amps, no, zero point 0.2 amps. And so that's sort of its initial current draw. So this side is getting really, like, I mean, it's considerably cold. So you can see the temp is not that different on my scanner, so it's saying 27, but to the touch it's actually much cooler. On the other side it should be getting a bit warmer, so here you can see that it's around 33, 34, whereas the ambient temp is around 27 ish. So yeah, it's heating up on this side, and then it's significantly cooler on the other, but the cold side isn't registering as much. So continuing with that, let's increase it to say 2 volts. And now the current consumption increases to zero point 0.5 amps. And here you can see that the cold side has actually significantly dropped to 23 degrees Celsius, and the hot side has increased to around 38 degrees Celsius right there. And it is again significantly cooler to the touch. Let's increase it once more. Okay, let's set that to 3. And now the current consumption has increased to 0.75 amps, and we are at 22 degrees on the cold side. Now it's really cold, and the hot side should be around 40, 45. Now I'm just going to go one more step and set that to 5, and hopefully that is not bad enough. So I'll just set that to 5 volts and see how hot it starts to get, which is around 56. The current consumption is now 1.25 amps, So it's 60 here, so significantly hotter to the touch. And on the cold side, it's around 26 or 24, where it needs, again, it's not, you are not pushing the heat out from here right now, so the cold side doesn't get that cold. So I've turned it off, um, and it takes its time to cool down. So the next and obvious thing to do is to attach a cooler to it, and let me just unplug the power supply. And the cooler I have is the cooler for some older AMD boards, which is basically a aluminium block with a fan, and the fan is going to help us a lot. This one. So I have to figure out how to wire the fan, which is probably just going to be ground and positive and run it at full load, or maybe I'll just connect it to the output here so that it still has like some sort of speed to adjust to as we are heating things up. So we'll put this somewhere like that in the center, and we will put that with a something called thermal cement, because I don't really have anything to hold. Alright, so I'm back after a lot of testing actually. So many hours later, we now have the tech element on the heatsink, and there's a fan beneath it. There's the fan blowing on the side of it. There's one fan underneath, as I just said. It's hooked up to the heatsink with the help of these two zip ties, but there's also a thermal compound. So I tried using the thermal epoxy or cement, but these didn't work like at all. They were, I think, too thick and nothing much to hold them down. So I ended up using a regular thermal paste. So a good performance thermal paste from Corsair, which you usually use for your desktop or workstation or gaming PC builds. And that worked really well. Transfers a lot of heat to the heatsink, and these two fans do a great job of blowing it away. And we'll see what the performance is like in a moment. It has been actually pretty neat. So I showed you guys 0 to 5 volts, but we are going to straight up jump into running it at 12 volts, which is its maximum rated voltage limit. So just going to power up the fans first. So they go on in a second, and that is the fans spinning, both of them. And then I will power on the supply, and then finally the tech at straight up 12 volts. So that's a 24-volt supply, and that's a buck converter. So as soon as I press on, that shoots up to 12 volts, and as soon as that happens, the tech actually goes negative 9, negative 15, negative 17. So the uh, the speed at which it cools down is actually pretty amazing. So you can see it just, if I have it right over the tech, it's around negative 23 right now. And it's, yeah, so this is sort of the place it maintains. Now from this point on, if I want to really chill it furthermore, I'll switch it off for a second. But if I really want to chill it more, I'd actually need to have better cooling solution, so a better heat sink with larger fins and a heat pipe and all of those expensive stuff, high RPM fans just to move the heat away as much as possible. So again, it goes to a negative, which is far below, or negative 20s, which is far below the dew point. So it reaches the frost point pretty easily. So I'm going to power it on once more, and I am going to leave it for about 15 to 20 minutes, and so you guys can have a nice time lapse of everything frosting up. And so I guess, yeah, enjoy. I'm just keeping it powered on for a while.